Welcome everyone. In this video class, we shall discuss about binary search. Now, binary search is nothing, it's just a program to search for any item from a list. As you can see in your syllabus and here also that it is a binary search in an array, but do not be confused. An array is same as a list. It's just a program to search for any number in a list, meaning suppose if I just pick 25, is just this program is going to show exactly where 25 is stored. Like, and of course it's going by index 0, 1, 2, 3. So 25 will be in the third index. And suppose if you pick 32, it's going to be in the fifth index and so on and so forth. So let's run this before I explain it to you. Now, you just have to enter any number. Let's say we enter 21. Okay, so it's saying 21 found at index 2. Okay, so if you say 21, it's really in index 2 because this is 0, 1, and 2. Let's run once again and we enter, let's say 32. When we enter 32, you will see that it's saying 32 found an index 5. That's because it is in the fifth index 0, 1, 2, 3, 4, 5. Now suppose if you enter something which is not in the list, for example 102 which is not there, so you will see sorry 102 not found in array. So this program actually what it's doing is just searching for an item from a list, right? And this is our defined list. So we have these numbers, but basically this technique actually is very useful. Okay, when you have to search in a large scale, which means if there are huge numbers, which means many numbers, let's say 1 billion numbers, and you have to search one from there. So this technique or this algorithm will help in searching that particular item from that list and just show where the index is. Now, apart from to understand binary search, you also need to understand there are a lot of other techniques, and one of it was is linear search also, which you are not going to do, but just to see the benefit of binary search, you should understand what a linear search is does and what a binary search does. In a linear search, what it does is the algorithm is such a way that each number is screened and matched with the item to be searched. Like for example, if you pick 32, 32 will be searched first, will be checked with 12, then 15, then 21, then 25, then 28, then it will get 32. And also let's say if you are searching 102, it will search I will check first with 12, then 15, then 21, then 25, 28, 32, 33, 36, 43, 45. So all the numbers it will check and then it will come to a conclusion that it is not there, right? So that is a linear search, right? Now, linear search, whether it is a 1 billion numbers, is going to run through all those 1 billion numbers and check each one of the number and match with the one that you are searching, which is not the case with binary search. Now, to understand binary search, okay, first you need to remember some of the things that we need to do in binary search. If we have a number in a list, of course, I'll just give an example of 10 numbers again, okay? So before searching, we have to enter the numbers in serial order, which means in ascending order or descending order. But then it should be in order. As you can see here, it is from smaller first, like 5, 7, 56, so it's increasing. So that is descending order. You can start from 327, 315, and so on. That would be your in descending order and not or in ascending order as you want it. Okay, so if you're going from a smaller to the highest one, it's called as ascending, and if you're going from a bigger one to the smallest one, that is descending, but it has to be in order. If not, what you can do is you can have another logic or technique to sort first all the numbers and make it in order like this, then we can start the binary search. So let's see now how binary search is done. In binary search, we get the middle index, okay, which I'm going to show you how do we get that. Okay, after getting the middle index, okay, through that index that we get the number as well, okay, which is stored in that middle index, and in this case it is 167. After that, we compare. Okay, we compare that 167, is it, you know, less or greater to that than that number that you want to search. Let's say if the number is 315 that you want to search, okay, then you it's just like check that 167 is greater or it's smaller. So you can see it is smaller than 315. So if it is smaller, so you understand that the number to be searched is towards the higher end. So that's when we will change our beginning. So we will just not look at the other section anymore. Just like we have divided half, we throw the half section and we start searching from this because we know it is towards the higher end. Again, we get the middle, and then if the index is 7, we through that we get the number which is stored there, that is 312. After that, again we compare if it is greater or less. If it is again towards the greater side, then we will take just this section and start searching from this, right? So if the number to be searched is 315, then in the first step now you will find its position, right? So this is the technique that we use in binary search. If you compare with linear search would have gone through all the numbers, but binary search, you can see it divide into half, as you can see, and then it search only the part that it needs to search. Again it divide half. Okay, so in that way the searching will be very fast, right? So this is of course better option or better technique in searching than linear search. Now the overview of the program before we start this. Okay, you have already seen the program that we have run. Okay, so this is just how we did in that mm, program. We had a size variable, you can say, to get the size. Okay, and then the item. Okay, the item means the number that you want to search. So let's say if the number is 315, they have entered. Then what we do is, this is, we get that the beginning, the first index. Obviously the first index is always 0. Now when I'm using this begin, this item, this last, this mid that you see here, they are all variable names. You can have another one, so I'm just trying to give a proper name to it. So this is a beginning. Okay, so that's why I'm giving begin equal to 0, and then we get the last one also, and the last one we get in this way. We don't just write 9, okay, because the list may be longer than 9 as well. Okay, it can be 100, it can be, as I've said, 1 billion also. So you cannot have the last directly as 9, so you use this technique. Last is equal to size minus 1. So you just take the entire size of the list, whatever size it may be, just minus 1 from there. So if you can see in this case the size is 10, so 10 minus 1 will be 9. So that's the initial part that you'll set the beginning and the last, right? So after that, what do? You get the mid, that is the middle section. And how do we get the middle? You just add the begin and the last. That means the first index and the last index you add, and then you divide by 2. Okay, that's when, that's how you're going to get the mid, right? So in this case 0 plus 9, if you divide by 2, you're going to get 4. Now wait a minute, you're going to say that it's is 4.5, but then we are going to take only the integer part, so it will be 4. Now with this 4, how do we get this number? This is how we write AR mid. Now mid is 4, so it's just like writing AR4. If we write in this way, it means we are referring to the number which is stored in this array or list name AR. And what's the index? According to this, it is 4. So obviously, this will refer to 167. So once you get that 167, you're going to check first of all whether it's equal to the item you're searching. If it is equal, then obviously it's done. But when in a program, we also have to check what if it's not equal. If it's not equal, it's going to go to the another if statement, the else if statement, and where we're going to check whether it's greater or it's less. Okay, suppose if it's greater, as I've said, if it's yes, then we are going to change the begin, because as I've said, this will be broken into half, and your begin will start from 5. And how do you get that 5? You get by saying begin is equal to mid plus 1. Okay, so your begin will start from here now. Okay, but suppose if it is less, if it is less, it means it is this side, so begin will remain 0, but your ending will be mid minus, or mid minus 1, which would be this one, because you've already checked, no, this 167. So 4 you'll not check anymore, you'll start till here. So if it is less, but if it is greater, then you're going to change only the begin. The last will remain the same, that is 9. So your begin is 5 now, and your last remains the same, that is 9. Okay, now how do we get the mid again? Begin plus last, that is 5 plus 9 now. Okay, and you divide by 2, you're going to get 9 plus 5 is 14, so you divide by 2, you'll get 7. So your mid now is 7. So when we refer to AR mid now, is going to be AR 7, which means 312. Once you get the number, again the first thing we are going to do is we are going to match whether it's equal or not. Otherwise we are going to check again if it's greater. Of course, 315 is still greater, so again we change the begin. The begin will be mid plus 1, so it comes to 8, right? So your mid is 7 plus 1, your mid will become 8, right? So your begin starts from 8, your last will be 9, your mid also will be 8. Why? 8 plus 9 is 17, divided by 2, then you get 8. It's 8.5, but we're taking only the integer part. Now when you check if it is equal or not, yes, it is equal. That's when you're going to return that particular index. So if the number is not found also, that also we are going to write. So what we're going to do is we are going to have error trapping for that. Okay, so there are chances where mid can go to, out of range as well. Okay, mid plus 1, so we have to check in a while loop that it does not exceed. Okay, so that's why we always say begin should always be less than the high, okay, the end one, so that it doesn't cross the size of the list, right? And also we are going to return something as to show that it is not there in the list. Okay, so in the next video I'm going to explain the class, okay, the video or the programs in Python.